All right, I started recording. Yeah. So tell me.
You can't end up with a negative um answer, and you also can't end up with zero.
Yeah, yeah. And let's look at why that was. So we're just gonna do a quick recap on logs, right? Quick
Okay.
recap on logs. Recap. So what does a logarithm function do? So just remember, a logarithm function consists of the base, argument, and the power, right? So let's just say, for instance, we had something like log base 4 of 16. What do you think the answer would be?
Two. Wait,
Do you remember what the log function is do?
it finds how much the base needs to be multiplied by itself in order to get the argument.
Wait, you're talking. I really struggling to hear. Try talking a bit louder.
It finds how many times the base needs to be multiplied by itself to get the argument.
Correct. So 4 to what power would be 16,
Two.
right? Because you would say 4 by 4 to get back 16. Nice. So that's essentially what the log function is do, right? Now, if you had something like log base 4 minus 16, is there any power I could raise 4 to that would give me minus 16?
No.
No, no, that's not possible, right? Because um no matter how much fours you multiply by itself, it will never get negative 16. Where's 4 by 4?
16.
Yeah, there's no instance where you would get negative 16, right? So that's why you said you can't find the log of a negative number. And let's do log base 4 of 0 now. Is there any power you could raise a number to that would give you 0?
No.
No. So this is also invalid. Right? So that was just a quick recap. And if I wanted to convert this from the log form to the indice form or the exponential form, how would I write that?
Um, 4 to the power of 2 equal to 16.
Perfect. Just remind me for the rules of logs or the laws. What are the laws for logarithms? Had three,
Um, I don't think I remember the correct names.
oh well, let me do it today, right? Um I surprised I'm not seeing Sheena in class. Usually she's early. I just messaging her mom. Give me a second.
Okay.
All right, yeah, let's continue, right?
Mm-hmm.
Before we look at the laws or rules for logarithms, I want to give you a question. So, Serena, say I wanted to figure out. So let me just say I had a question, right? And the question was 3 to the power x is equal to 71. How would you answer that? That's the question. How would you answer that? What would you have to use to figure that out?
You'd have to use the log base function in your calculator.
Right? I
And
would have to use the log base function. So in this question, what's the base?
the base is 3.
Right? What's the power?
X.
And the argument is?
71.
So I'll write log of the base, which is 3. Argument is 71, and that's supposed to give me the power. So let's verify that on the calculator real quick. And Serena, what kind of calculator?
Casio.
Right. We don't deal with nothing else. Right? I'm gonna get some enemy. Why does this thing keep boy this thing annoying? I don't like that. All right. I'm gonna get some haters for saying that, but I don't mind. They clearly haven't used a Casio before. All right. So we're going to put log base 3, 71, and that's going to give us 3.8800588435. Cool. So that's the answer for x. If I round that off to 2 decimal places, I'm going to get 3.88. Yeah?
Yes, sir.
Cool. Now, if I were to remember how to store a value in a calculator, how to store a value?
You would need to press shift, then store.
Wait, in your calculator, does it have STO? Does it have the store button or does it have the recall button primarily in white? So
It
in my
has,
calculator, I have store in white. What do you have it in?
I have recall in white.
Okay, well, you'll have to press shift recall to get store,
Yeah,
right? So you are going to press shift recall. Well, I'm just going to press STO, but you'll have to press shift recall, okay?
yeah,
Then you're going to press any button from the top row. So the one with the red A, red B, red C. I'm going to store it under A, right? So after you press Shift Recall, then select where you want to store it under. I want to store it under A, so I press the open close bracket with the minus sign in the middle. All right. Then you're going to press equal. Then you're going to clear the calculator. Say with me so far?
yes, sir.
Right. To get it back, you would just have to press the recall button. I would have to press Shift Store. Right? So you press the recall button and then you press the button you stored it under. Right? And you should get A. You should be seeing A on the screen.
Yes,
Right? So if we want to check our answer, we're going to put 3 to the power and we're going to recall what we said A was. Now, if this is correct, it's supposed to give us what? What is it supposed to give us?
71.
Bam. I'm a magician. Right? I'm a magician. Right? So it does work. We are correct. So that's a quick recap on the log function. Let's just do a recap of the laws now. The laws slash the rules.
Alright.
Right? Rules. So the first one is the product rule. What does product sound like?
Multiplication.
Multiplication, right? So imagine I have something like log base A B, right? I have log base AB, and I'm adding that to log base AC. What would that be equal to, Serena?
Would be,
If it's saying the product rule, try to remember from the previous session what that would be equal to.
it would be equal to log base A BC.
Yes. Do you know why?
Um,
I want you to be real with me. Do you know why that's how that's work?
I knew why, but it's not coming back to me.
I don't think I showed you all the reason why. So I'm gonna show you it now, right? So
Okay.
when you use a logarithm function, what are you finding for, Serena? You're finding for the what?
The power.
Exactly. So these two things are what? What are those two things? It's not looking like it, but we know that they are what? So that's a P.
Product.
Powers.
Or powers.
Remind me, Serena, if I put log base 371 enter finding for a power,
Yes.
yeah, so and I'm asking this, isn't this a power?
Yes.
And isn't this a power?
Yes.
If you're adding powers, to add powers, and you would have to multiply the bases.
Yes.
Let me show you an example of what we're talking about. Imagine you had 8 to the power 3, right, multiplied by 8 to the power 4. Wouldn't that be equal to 8 to the power 3 plus 4?
Yes.
You see the relationship I'm talking about? I'm saying that these are powers. So if you add in powers, it should be equal to the product of the arguments. Wait, that might confuse you. So check this, right? Check this, Serena.
Mm.
What is 8 to the power 3?
8 to the
Tell
power 3.
Yeah, what is 8 to the power 3?
512.
What is 8 to the power 4? Well, let me see if I can calculate that. I think that's going to be 4096. Tell me if that's correct.
It is.
Okay, abad and abad, abad. I probably can't do this multiplication in my head though. I don't think I could do 512 by 4096. All right. Well, what would that be equal to?
Um, it would be equal to 2,097,152.
That's it?
Yeah.
So Serena, let me check something, right? Let me check something. Let me see if this making sense. So if I put log base, the base here is 8, right?
Yeah.
Right? For 8 to the power 3, the argument would be 512. Yeah or no?
Yeah.
Okay. So if I put log base 8, 512, and I add it to log base 8, 4096, that's supposed to be equal. So again, Serena, and this just means, and this just talking about the powers. It looking a bit different, but and this is just the power.
Yes.
Yeah. So if I know, right, that 512 is the same thing as 8 to the power 3. So the power for this is 3. And what's the power for this one?
4.
Right. So 3 plus 4 is?
7.
Right. So Serena, that makes sense, right?
Yes, sir.
Now, look at how this is gonna work, right? And if I multiplied 8 to the power 3 by 8 to the power 4, I'd get 2,097,152.
Yes, sir.
Isn't that the same thing as log base 8? Wait, isn't that the same thing as 8 to the power 7?
Yes, sir.
Let me see. Let me just verify that. 8 to the power 7. It is. So, and then I could write 7. And I could write 7 as log base 8. 2,097,152.
Yes.
Yeah. So everything making sense. The whole reason why we're saying product rule is because we're talking about the addition of powers. And that's what we're doing. I know it don't look like powers, but when you use the log function, you're finding for a power. So to add powers, you need to multiply. Make sense?
Yes, sir.
Say no more, right? And if the product rule is is adding powers, so you multiply. What do you think the quotient rule is?
It would be division.
Exactly. So you would say instead of plus, you're gonna minus powers. And Serena, if you want to minus powers, then you'd have to do what?
Of divide.
Divide, right? Yeah. Think about it. If you had 8 to the power 7, right, divided by 8 to the power 4, wouldn't that just be equal to 8 to the power 7 minus 4, which is equal to 8 to the power 3?
Yes, sir.
Right. So in this particular example, this could have be power 7 minus the power 4, right? And that would be equivalent to 8 to the power 7 over 8 to the power 4, which would just be 8 to the power 3. So your answer would be 3. And if you don't believe me, let me check it out. So if I write down log base 8, 7 minus, wait, I would need to actually plug it into my calculator, right? I would actually need to find what 8 to the power 7 is. So 8 to the power 7, we know what that is, right? That was the um, the 2,097,152 minus log base 8. And 8 to the power 4 was what? 4,096.
Mm.
All right, so Serena, I know it don't look like it, right? But this is just telling you the power you'd have to raise 8 to get the answer. And the power would be 7. So this whole answer is 7. What would this whole answer be?
4.
log 4, right? So whatever I write here, it has to be 3. And how would I write 3 in terms of log base 8? Well, I would write log base 8, and I would write 8 to the power 7 divided by 8 to the power 4. So Serena, in a calculator, I want you to put 8 to the power 7 divided by 8 to the power 4. And tell me what number you get it.
I got 512.
Right. So does it make sense? If you put log base 8 512 in the calculator, are you getting 3?
Yes, sir.
Yeah. So it makes sense. If you are minusing powers, you have to divide. So I hope everything clicking and nothing confusing. The third rule we're going to look at is called the power rule. So imagine if you had something like log base AB to the power C. I could write that as C times log base AB. And you might probably be confused, but wait, I'm gonna show you why this is not confusing at all. So Rena, if you had something like log base 8, what would the answer be?
1.
The answer will be 1, right? The answer will be 1. Now, and the whole point of the log function is to give it the power.
Yes.
Yeah. So if I had something like log base 8 to the power 3, and it's already have the power over here.
Yeah.
So what do you think this whole thing would be equal to?
Um,
Serena? Serena, let me know if you're there.
yes, I'm there.
Yeah, you have idea, so what the answer might be?
It would be 3 log 8.
Yeah.
And
No, it could just be 3. It could just be 3. Let me show you why. Put 8 to the power 3 in your calculator. What is 8 to the power 3?
512.
You sure? Okay, yeah, that's correct. So, Serena, if you have this, wouldn't the log function ask you, okay, what would I have to raise 8 to get 512? And that is where it would ask you.
Yeah.
You would have to raise 8 to what power?
3.
So if I have 8 to the power 3 already, and it's literally telling us that, well, you'd have to raise it to the power 3.
Oh, yeah.
Yeah, you see it?
Yeah.
And so if since they would have recognized that's what's happening, and they came up with the power rule, because Serena, check this, right? Anytime you have the same base, or it doesn't even matter if you have the same base. Anytime you have the base to some power, you could always bring it to the side. Because watch this, right, Serena? And we know the answer gonna be 3.
Yeah.
We know the answer gonna be 3. So I could take that 3 and bring it to the side and write that as 3 times log base 8. Where's log base 8?
1.
Where's 1 by 3?
3.
Bam. Make sense?
Yes, sir.
Nice. Makes perfect sense. So those are the 3 rules you need to remember at all times. At all times, right?
Yeah.
Now, when you're doing logarithmetic, I hope I spelled this correct. Okay, I spelled it correct. I'd always be scared to spell that wrong, you know. I'd always be scared to spell that wrong. So if you're doing a logarithmetic equation, here are the things you need to keep in mind.
Mhm.
Number 1, every term must have the same log base. Every term must have the same log base. If it does not, you have to convert. If it does not, you'd have to convert. That's what you would have to do. And let me give you an example of what I'm talking about. So, Serena, imagine you had something like log base 3, 9, plus log base 3, 27, right? And that's equal to, okay, wait, actually, let me change this to x. All right. So Serena, if you saw that logarithmetic equation, right? This term has log base 3 in it. This term has what in it?
X.
That's not the main thing. Look at the base. What's the base?
Base 3.
Base 3.
Mm.
Does this have base 3?
No.
No. So that's a problem, right? It's not in terms of log base 3. So we have to do something about that. Yeah?
Mm.
Now, at all times, I want you to tell me if I'm losing you, right? So over here, notice that we have the same base and we're adding. So what rule could I use?
The product rule.
Yes, I could use the product rule. So I could say log base 3, 9x. That confuse you or you're good so far?
Good so far.
Okay, good. And 6 is a problem. Now, Serena, check this. And if I wanted, I could write that as 6 by 1.
Yes.
I think you probably see where I'm going with this. What's another way to write 1 if I use in log base 3? So Serena, you just told me log base 8 was 1. What do you think 1 would be in terms of log base 3? So there's another rule I should probably write down to formally know it, right? This is a fact. If you have log base a, that will be equal to 1. An example would be, again, log base 8 is equal to 1 because you'd have to raise 8 to the power 1 to get 8, right?
Mm.
So what's another way to write 1 in terms of log base 3?
3.
Exactly. And you would have to raise, okay, again, logarithm functions find any power. And to get, if you have a base at 3 and you want to get 3, and you would have to raise 3 to the power 1 to get 3.
Yeah.
So if I plug that into the calculator, log base 3 is still 1. Did we do anything crazy? Did we break any laws?
No.
No. And my question to you, right? Is everything in terms of log base 3 now?
Yes.
Not so fast. Not so fast. You see how we have that 6 over here?
Yeah.
Is there a rule I could use to simplify this or condense it? I have a 6 to the side. Is there anything I could do with that 6 to the side?
I'm not sure.
Let me check out the power rule real quick.
Mm.
Check that out. So these rules work back and forth. So if I have a base raised to a power and I can move it to the side.
Yeah.
So if I have a base to the side, we think I could also do with it.
Move it to the front.
Exactly. I can move it to the front. So if I have 6 log base 3, what I could also do with it?
You could write it as log base 3 to the power 6.
Exactly. Exactly. Right? Serena, did I change anything? Or is it still correct?
It's still correct.
Exactly, because in this line, we have 6 by log base 33. Log base 33 is what?
1,
Right? 6 by 1 is?
6.
Okay. If I have a base of 3 and I'm trying to figure out, well, I would have to raise that by to get this. Since I already have since I already have 3 over here to the power of 6, and the answer would just be 6.
Yeah.
Yeah, so, and this is still equal to 6.
Yes.
And if at any point you have trust issues, you could verify it with the calculator, right? Log base 3 to the power of 6, 6. Yeah,
Okay.
cool. So my question now, did I simplify everything as much as possible? Do I have one log term on either side? Tell me, Serena, are you seeing any other log terms, or are you seeing one log term on that side?
1,
One. How much log terms is seen on that side?
1.
You one, that's right. Are they the same base?
Yes.
Yes. So now anytime they're the same base, you could go ahead and drop the logs. So if I drop the logs, what would I end up with?
9x equals to 3 to the power of 6.
Right. What is 3 to the power of 6?
729.
Nice. And if I wanted to find for 1x, what would I have to do?
You'd have to divide both sides by 9.
Right. You want another way to think about it?
Sure.
If you had something like x plus 5 is equal to 10, and to find for x, you'd move across the positive 5.
Yeah. And it would be negative 5.
Perfect. So it's the same concept over here, right? 9 is being multiplied by x, and
Yeah.
so if I move across 9, it will change to what?
Um, Divided by 9.
Yeah, exactly. It's another way to think about it. So x would be equal to 729 over 9. That should be 20. No, I'm not sure. Actually, not sure. What would that be equal to? 729 all over 9, 81. Just verify that again, 81.
Yes, I did.
And if you wanted to check if your answer is correct, you could always plug it back in and make sure it given you 6, right? So let's see if that's the case. So Serena, log base 39 is what? What's log base 39?
3.
Nah, 3 to what power is 9?
Oh, 2. 2.
2. So that's gonna be 2 plus log base 3x, x is 81. So if x is 81, it's gonna be log base 381. Let's plug that into our calculator. Log base 381. And that's going to be 4. So this was 2, and this was 4. So altogether, that's 6. Is it correct?
Yes, sir.
Nice. So let me run through the general steps, right? First of all, Serena, you're going to ask yourself, is every term the same log base? If the answer is no, you'd have to convert it using these rules. You would have to use log base a, right? And you'd need to multiply it by some number. In this case, Serena, and we had to multiply log base 3 by 6.
Yes.
Yeah. And then the other step is you're going to take that number outside and you're gonna use the power rule. So you're gonna bring it up to the top, make it a power. Right. So again, let me run through these steps. If every term is the same log base, you're fine. If it's not, you change it. Right? The next step would be to apply rules. So Serena, notice that to the left hand side, enter had the same log base and I was adding.
Yes.
So which rule did I apply to condense it?
The product law.
Right? So you're gonna apply rules to condense. Once you have once you have one log term on either side, drop the logs. Yep, that's it. And last step is just solve algebraically. Solve. I'm surprised I spelled that word correctly. I'm very surprised. Right. So you could copy that down as an example. That's more or less everything you need to know when dealing with logs. All right, so Serena, is there anything that's making your head want to explode or you understand everything so far?
I understand everything so far.
Nice. Now, here what is Serena, things gonna change drastically when I put a minus sign in the middle. If I put a minus sign in the middle, you're gonna have to cross multiply. So you're gonna end up with a quadratic, all kind of bacchanal. So we'll do some more examples.
Okay. I'm finished copying it down.
Wait, but use Flash, use Barry Allen. All right, good. So let's do some questions now.
Okay.
It's like nobody's who add maths boy. Like I get a good bit of math students, but I don't know why it's so hard to get art math students. Like I don't know why. It was weird. The art math schooling, like the art math class in your school is big or small?
There's three classes of 22 people in each class. So 66 people doing ad maths.
Everybody doing art maths?
I don't think there's everyone, but
So that might be a little less than 66.
huh?
I say that might be a little less than 66.
Well, each there's three ad math classes, and each of them
Oh,
contains 22 people.
oh, okay, okay. Well, before the term end, I want to get at least 10 to 15 people in class. I don't know. It seems, I don't know, it's something hard. So I don't know why it just feel hard, right? Shayna's supposed to join any minute now. I don't know what she did. All right. Are you ready to try a question by yourself? That's the question I have for you.
Yes.
Okay, word. I like that confidence. So I starting you off moderately easy. So how much time you think I should give you for this question?
Um, 3 or 4 minutes.
I give you 4 minutes. I'm feeling generous like Santa Claus today. I can't wait for Christmas, boy. I can't wait for Christmas. You know why I say that?
Why?
Because my birthday is in Christmas.
Oh, that's nice.
Yeah, but the problem is I was get a Christmas gift and a birthday gift in one.
Oh,
Yeah.
is it on Christmas itself?
No, 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 no. I born on the 8th of December.
Mm,
Are you born on December as well?
no,
Let me guess. February,
no,
June,
no.
November.
Mm-mm.
Okay, damn. I don't want to just keep guessing.
August.
Oh, so your birthday was last month.
Yeah,
Well, happy late birthday, right?
thank you.
Happy late birthday. All right, so 1 minute and 30 seconds. Your phone really going off.
No, oh, you can hear that. I'm sorry. Oh,
Yeah. All right, so we're done. Did you get through?
Almost.
Almost? Okay.
Should I send the answer?
Yes, send the answer on WhatsApp. Will you be watching the Demon Slayer movie?
No.
Oh no, you're not into anime.
I am, but I've never reached Demon Slayer yet.
What? That's crazy.
I know.
That's crazy. I can't believe that. What?
That's where I reached so far.
Okay, so one thing I'm noticing, right? I notice I have two equal signs. There's no need to put two equal signs. That equal sign to the left, yeah, shouldn't put that. It should just be log base 5 x plus 2 by x plus 6 equal to 1. There's no need to put another equal sign.
Okay.
All right, so let's do the question on the screen. First things first, I realize that I have the same log base and I'm adding. So I'm going to, I could write that as x plus 2, right, by x plus 6. And that's going to be equal to 1. Now, 1 is the same thing as log base 5, 5. So I can make that change one time. If I do this, I can now drop the logs. So, Serena, can you see that? Let me ask you this, right? How much log terms are you seeing on either side?
One on each side.
1. So we could drop the logs. If I drop the logs, I'm going to end up with x plus 2 by x plus 6. And that's going to be equal to 5.
Mm.
Confusing or no?
Not confusing.
I see that you didn't drop your logs.
I, I don't know
Serena?
how I didn't reach there yet. I don't know
Oh,
why, but whenever I do questions, I do like every single step on every line because it helps me see it better.
that's not a problem as long as it helps you. That's not a problem.
Okay.
So now let's expand. If I expand this, I'm going to say x by x, then I'm going to say x by 6, then I'm going to say 2 by x, and then I'm going to say 2 by 6. So I'm going to get x by x, which is x squared. I'm going to get x by 6, which is 6x. I'm going to get 2 by x, which is 2x. And I'm going to get 2 by 6, which is 12. And here what, Serena? This starting to look like a what? What is it starting to look like? Starts with Q,
Quadratic.
a quadratic. So quadratics would look like this. It would be ax squared plus bx plus c is equal to 0. It's always equal to 0. So what do you think I should do that 5 on the right hand side? Do you think I should leave it there or you think I should move it across?
Move it across.
If I move across plus 5, what would it become?
-5.
Right? And since I moved across everything that was on your right hand side, what would it have on your right hand side now?
0.
Yep. Let's simplify. So x squared, notice we have two like terms for x. We have 6x's and we have 2x's. So altogether, that's going to be what?
8x.
Right? 8x. And what is 12 minus 5?
7.
Right? Now we need to factorize. So to factorize a simple trinomial, meaning that if you confuse trinomial, tri means three, and you have three terms.
Yeah.
So this is an example of a trinomial. A trinomial too. It's a quadratic, but you could also call it a trinomial. The coefficient of x squared is 1, so we call it a simple trinomial. And this is very easy to factorize. So Serena, to get x squared, how would you get back x squared? What is x squared?
X by x is x squared.
Right? How would I get back positive 7? I think of two numbers you could multiply to get back 7 and add to give you plus 8. So how can I multiply to get 7? What is 7?
1 by 7,
And if I add 1 and 7, what would I get?
8.
So does it sound correct?
Yes.
Yes, because 1 by 7 multiplies to give me the last term and it adds to give me the middle term. So it's definitely correct. It doesn't matter where you put the plus 1 and the plus 7 because both of them are positive. It'll work out regardless. Right? If you had trust issues and you wanted to check if it was correct, you could just simply expand. If I were to expand this, I would get x by x is x squared, x by plus 7 is plus 7x, plus 1 by x is plus 1x, 1 by 7 is plus 7. 7x plus 1x is 8x. Do I get back what I originally had?
Yes.
Right? So we're fine. We're fine. Now, since we wrote it as a product of factors, I could now equate each factor to 0. So I would say x plus 1 is equal to 0, and I would say what?
X equals to negative 1. Oh, x plus 7 also equals 0.
All right, so it was correct. X is equal to negative 1, and over here it's going to be x is equal to
Negative 7.
perfect. Now, remember what I was telling you. You can't find the log of a,
Negative number.
right? You cannot find the log of a negative number. So do you think both answers are incorrect?
Um,
Tell me, Serena, do you think both answers are incorrect?
I think the negative 7 is incorrect.
I agree. Because if you look at and let me show you how you'd actually verify, right? So to figure out which answer is invalid, plug the x values into the so just from memory, well, not from memory, I'm gonna pull it back. The original equation was log base 5 x plus 2 plus log base 5 x plus 6. So Serena, um, which one you want to try first? X is equal to negative 1 or x is equal to negative 7?
Negative 1 first.
Okay, so if I put in the negative 1, then this bracket would turn to negative 1 plus 2. What is negative 1 plus 2? 1, right? What is negative 1 plus 6?
5.
Did I get any negative numbers there?
No.
Right? No negative numbers. X is equal to negative 1 is correct. I probably shouldn't write it in red because, we just associate red with being incorrect. I'll write it in green. All right. Okay, what if I were to try plugging in x is equal to negative 7? What do you think would happen? Do you think I'd end up with a negative number?
Yes.
Yeah. In one of those brackets, you'll end up with a negative number. So that would be -7 plus 2. What's -7 plus 2?
-5.
Ah, that's a red flag one time, and that's a red flag.
Mm.
Wait, let me find a meme to put here. Yeah, that's a red flag. What about flipping -7 plus 6? What's that?
-1.
Yeah, let me get another one. Right. Uh, X is equal to -7 is invalid because it gives us negative values inside the log function. Right. So you could go ahead and make the necessary notes. You seen everything on the screen?
Yes, sir.
Yeah? Okay, cool. Will you be drawing the memes as well?
I'm not a very good artist, so no.
Oh, shucks. So here what? As soon as you have this copy down, I'm going to give you a new question and I want you to redeem yourself. Try to finish it in 4 minutes. Yeah. Serena, do you know the meme? Do not redeem it.
I've probably seen it, but
You know the Indian meme where they be like, do not redeem it. You know that one? Like with the call centers?
yeah.
Yeah. Well, I'll give you a chance to redeem it.
I'm finished.
Okay, great. Do you write neat? I'm just curious.
Sometimes.
Okay, sometimes. All right. Let me give you a chance to redeem it.
Mhm.
So I given you 4 minutes, right? And I think in 4 minutes you should be able to lock in and get the correct answer.
Okay.
Right? So log base 3 x. So by the way, if you get a question on this, it might be word formats. And if you don't put, say, see how I checked if my answers were correct? You need to show that as well. You need to show that, you need to show why x is equal to -7 is not a solution.
Okay.
A lot of students, when they do any question, they would just see negatives and just put as wrong. And they would lose like what, 3 marks, 3 to 2 marks. Don't be like that.
Okay.
You actually need to put it into the original equation and see if it's giving you a positive or negative within the brackets. Be wary of that. Do you know your Casio calculator could solve this for you? Like if you could plug this whole thing into the Casio calculator, but I think your calculator didn't have the function for that.
Mine didn't.
So there you go. Take 4 minutes and 30 seconds. So Serena, I hear that Shane will be joining us shortly.
Okay. finished.
Okay, cool. Send me a picture. Oh, you already sent it. Cool. This one was easier because you didn't have no conversion to do, right?
Yeah.
So let's speed through it quickly. So first things first, I'm going to apply the product rule on the left-hand side because we have the same base and we're adding. So that's just going to be x plus 2 by x minus 1. I like to put extra pair of brackets just for safety, right? Because because here what, right, Serena? If you were to expand it, so if you were to expand that, you would get x squared minus x plus 2x minus 2, right? So Serena, if you do that, that's kind of wrong because it might interpret it as log base 3x squared, right? Minus x plus 2x minus 2. But that's not the case, right, Serena? Serena, as a matter of fact, and it's supposed to have another pair of brackets to like to symbolize that we finding the log base of that entire thing.
Yes.
Yeah, so you should put an extra pair of brackets on the outside.
Okay.
Sheena, Sheena, we
Good evening, so I'm so sorry. I wasn't home.
everything okay?
Yes, so I just woke late. So yeah.
Okay. You think that like does this happen often? I just curious. Because if
Um,
it does happen often, I could consider starting class at 5.
no, so it doesn't. But I generally reach home like around mid to 4. But yeah.
Okay. Well, if I notice it happening frequently, I'll just obviously not intentionally, right? I'll talk to your mom, make sure it's like unintentional. But if it keeps on happening and you can't avoid it, I'll move class to 5 to 7. Right?
All
So
right, so
yeah,
thank you.
no problem. So Sheena, what we did, I did a recap on logs and I just doing logarithmetic equations now. That's what I'm doing. Right? So Serena, let's continue. So tell me, Serena, do I have the same log base on either side?
Yes, sir.
Do I have the same, do I have one log on either side? One log. Yeah? If you have one log and it's the same base, you could drop the logs. If I drop the logs, I'm going to end up with x plus 2 by x minus 1. And that would be equal to what, Sheena? If I drop the logs on both sides, what would that be equal to? Tell me, Sheena.
6x minus 8.
Right. Sheena, let me see if you can expand this without arrows. Expand this one.
X squared plus 2
No.
plus 2x. Oh, sorry, minus 2 is a negative, right?
Wait, don't take your time. So x by x minus 1, right? And 2 by x
Oh,
minus 1.
sorry, oh crap. Then x squared plus x
Nah,
plus
minus
2x.
x.
Oh crap. Oh
Minus
my
x.
goodness.
Take your time, take your time. It's not like you run a marathon to come home.
So I know.
Oh, all
Okay.
right.
Then positive 2x and then minus 2. I mean positive x. I mean, yeah, no, positive 2x. What?
No, you say the correct
Is
thing. You
it?
say the correct thing. You
No.
say the correct thing.
I think in the
You
correct
said
thing I seen the wrong.
right? And here what it's starting to look like a quadratic. Remember, um, quadratics is typically be in this form: ax squared plus bx plus c is equal to 0. Yeah. So if that is the case, we should probably move across that 6x minus 8. Shina, if I move across 6x minus 8, what am I going to write on the left-hand side?
0.
Left-hand side. So the side that I'm moving it
Oh,
across to.
sorry. Yeah, change the signs of the figures. So minus 6x plus 8.
Right, and that'll be equal to 0 because I move across everything from the right-hand side. Mm-hmm. And so now let's try to group together the like terms. So Sheena, we have minus x. Are there any other like terms? Any other like x terms?
Minus 6x.
And
Positive 2x.
right. So if you want to do that quickly, you can just put the coefficients into the calculator. So minus 1 plus 2 minus 6. Minus 1 plus 2 minus 6. And that's going to be minus 5. So that would be minus 5x. For anybody that confused, watch minus 1 plus 2. Minus 1 plus 2 is 1. And then 1 minus 6. 1 minus 6 is minus 5. That's all again minus 5x. Right? And so now, are you all seeing any constants? Are you all seeing any constants? Constants is just a number.
Yes, sir.
Yeah, tell me the numbers you guys are seeing.
Minus 2 and positive 8.
Right, what's minus 2 plus 8?
I'm sorry, so 6.
Plus 6, right?
Positive
So
6, yes.
so Sheena, let's factorize this. If I factorize this, I'm going to look at the first term. The first term is x squared. What would I multiply to get back x squared? So Sheena, tell me, what by what is x? What by what would give you x squared? Sheena, are you there? Okay, I'm not hearing Sheena. Serena, you want to tell me what by what is x squared?
X by x is x squared.
Right? X by x is x squared. And Serena, you want to tell me what I would have to multiply by 6? No, what's it? Can you tell me what you would have to multiply to get 6 and add to get minus 5?
Negative 2 and negative 3.
Tell me that again.
Negative 2 and negative 3.
Right. Negative 2 by negative 3. Remember, negative by negative is a positive, so 2 by 3 is 6, positive 6. Right? We get the last term, and if you add minus 2 and minus 3, you'll get minus 5. If you don't believe me, watch. Minus 2 plus minus 3 minus 5. Cool. So Serena, we in the clear. We good. Again, it doesn't matter. Once it's a simple trinomial and the coefficient of x squared is 1, doesn't matter where you put the factors. So I could put minus 2 here if I wanted. I could put it over here. Doesn't matter. Right, so we get x minus 2 by x minus 3. So if this is the case, Serena, I'm going to say x minus 2 is equal to 0, and I'm going to say x minus 3 is equal to 0. So, what would the answer be for this one, Serena?
X would be positive 2,
And x would be equal to what here?
positive 3.
Now, just by looking at it, these two solutions look valid, but we have to put it back into the equation to see if it's really valid, right? Just by looking at it, it does look valid. Let's see, right? When x is equal to 2, let's see what's gonna happen. So tell me, Serena, if x is 2, this bracket gonna turn to what?
2 plus 2.
This bracket gonna turn to?
2 minus 1.
And this bracket gonna turn to?
6 in brackets 2 minus 8.
So we're gonna end up with log base 3, 4. Is that valid? Yes or no?
Yes.
All right. Then we're gonna end up with plus log base 3. 2 minus 1 is 1. That's valid. By chance, Serena, what would the answer for this be? Yes, any number to the power 0 is 1. And that would be equal to log base 3. 6 by 2 is,
12.
right? 12 minus 8. 12 minus 8 is just 4. So is x is equal to 2 a valid solution?
Yes.
Right. X is equal to 2 is valid. Nice. Let's check if x is equal to 3 is valid now. When x is equal to 3, Serena, if you could only copy and paste like that in the exam, eh? Hard luck, eh? Hard lucks. Well, you can't do that, right? Let me just speed through this quickly. Right. So, Serena, x is 3, x is 3, x is 3. 3 plus 2 is 5. 3 minus 1 is 2. 6 by 3 is 18. 18 minus 8 is 10. Is everything correct there?
Yes, sir.
Nice. So you would say x is equal to 3 is valid. So my answers will be x is equal to 2 and x is equal to 3. So you 100% understand that question. Like you properly understand it.
Yes, sir.
Great. What if so Serena, the whole time we're looking at the product rule. Let me change up things and use the quotient rule now. Let me see how you're gonna handle that. Shana, are you there?
Yes, sir.
Okay, Shana, because I want to do a question with you. I know you're gonna miss out on some stuff. And from your track record, I think I could believe you. I think you might watch back the video. I think. I kinda trust you now.
I will.
You can you build up the trust. I trust you now. I feel like I don't trust you because it is always sound kind of sketchy. If that makes sense. I don't know. It is always sound a little nervous.
Oh,
Like
okay.
you have something up your sleeve. But I realize that's just how you just talk. I realize that's just how you just talk.
Yes, sir.
Right. So this is a tricky one. This is a red flag. We don't pass sticker for this one. Um, right. I've got delete it. Yeah, gonna give Olive 5 minutes for this one. Shayna, you could try it. You could try it. All right, so Serena, give it a go. Serena, you feeling like to jump off a bridge? Or like you feeling like you have this under control? Like you're cooking.
I think I have it under control.
All right, nice. Shayna, how you feeling?
I'm gonna attempt it. And you'll see.
Okay, we go see. You go do the question, all right? You go do the question,
What
okay?
you say?
Yeah. Serena, see a bad, bad. Hey, big up you. Okay. All right. Serena, you ready for them? Ain't you ready for CXC?
Sure.
CXC in C, what coming next? I don't know if you see what I did there. Capital C. Yeah. All right. Just verify. Wait, Serena, if you wanted to check if your answer was correct, how would you do that? How would you do that?
You would plug x equals 26 into the original um,
The
equation.
original? Yeah. Let's see if your answer is correct. 3 by 26. Plus 7 minus log base 3.
It's log base 5 root 3.
Ew. I tell you, I need to change my glasses, you know. I'll get new glasses soon. I don't know if that will help. Think I just, I think I'm more than blind at this point, right? And that's gonna be 26 minus 9. So fingers crossed, when I press equal, what it's supposed to be?
1.
Yo, it work. Wait, big up you, big up you. Maths is very cool. Maths is very cool. Yeah. Because if you look at that, you might probably be scratching your head. Like, how the jail am I going to figure out for X? But you did. You figure out for X. Right? Nice. So Sheena, let's try to attack this thing now. All right. So Sheena, put on
Yes,
your
sir.
mic and let me speed run this. Well, not really speed run it. You joined a little late, so I don't want to speed run it. So let me just go through the rules, right? So you're supposed to remember that had these three rules: the product, quotient, and the power rule. And number 4, if you have the same log base, right? So like, okay, if you have log base a, that will be equal to 1. Shayna, do you remember what a log function is do by chance?
You want me to find power?
It's finding power. Yeah. So you understand why log base 8 will be 1. Because to get back 8, you'd raise 8 to the power 1. Yeah?
Yes, sir.
Cool. So the product rule says if you have the same log base and you have an add sign, then you would multiply the arguments. Cool. The quotient rule says that if you have the same log base and you're minusing, you would divide the arguments. Cool. And the power rule, it's in the name power. If you have a power, you can move it to the side and vice versa. So Shayna, if you wanted, you could have take the power and bring it back up. Either one works. Depends on the scenario. Something I need to tell you, Shayna. So when you're working with logarithmetic equations, every term must have the same log base. So Shayna, when you look at this question, does everything have log base 3 in it?
Yes, sir.
Yeah? Where's the log base 3 over
Oh,
there?
sorry.
That's kind of suspicious. Where's the log base 3 over there? So tell me, Shayna, N6 is the same thing as 6 by 1.
Yes, sir.
And if I have log base 3, I could write that as, okay, if I'm dealing with log base 3, right, and I wanted to write 1, that would be the same thing as log base 3 what? 1 would
No
be the
issue.
same thing.
Mhm.
Log base 3 what? Log base 3 what?
Times 1.
Log base
Wait,
3
sorry.
7.
What? So where's the 1 come from?
I hear you say 7.
Yes.
Log base 3 what?
Oh my goodness. Sorry, not you. The noise. Anyway, times 1.
Serena, are you hearing her say 7 as well?
I'm not sure what I'm hearing because
You're
I
not sure
have
what you're hearing.
yeah.
So Shayna, let me run through this again, right? So Shayna, I have this rule over here that says log base a is equal to 1. And we know that. We know why. Because
Yes.
the log function allows you to figure out what power you'd have to raise a base to get the argument. Right? So Shayna,
Yes, sir.
and to get 8, you'd have to raise 8 to the power 1. So the answer for that will be 1.
Yes, sir.
So how would I write 1 using log base 3?
You're easily poetry. I mean, we have part 3.
I'll put 3, right?
Mhm.
And this, just remind me, this over here would be the what? The base argument power. What would that be?
That that's definitely something I remember.
Shayna,
Your base,
right? As the base. What do you think 3 is?
the arguments,
Right? And 1 is the?
power.
Right. Remember, log function gives you power. Nice. So in this question, we had 6. Now, 6 was not the same thing as log base 3. It wasn't in terms of it. So we changed that to 6 by 1. 6 by 1 is still 6. And Shayna, and 1 is the same thing as log base 3.
Yes, sir.
Right? And then I'm going to apply the power rule. I have something to the side, so I could take it and bring it up to the top. So now I have 3 to the power 6. So let me ask you a question, Shayna. Do I have one log term on either side?
Yes, sir.
Right. How much log terms is in here?
1,
How much log terms is in here?
1.
Are they the same base?
Yes, sir.
Once it's the same base, you can drop it and then solve algebraically. Smooth sailings from there. Now, tell me, Sheena, in this question, do we have the same log base on the left-hand side and on the right-hand side?
No, sir.
Nah. On the left-hand side, could we apply any of the rules?
The quotient rule.
Yeah, I could apply the quotient rule. If I apply the quotient rule, I'm going to get log base 5, right? You tell me what to write. Log base 5.
3x plus 7 over x minus 9.
Mm-hmm.
Equals log 5, 5.
Correct. What if instead of 1 I had 2? What if instead of 1 I had 2? How would I handle that? Tell me, Sheena.
Um,
Do you know?
no, sir.
All right. Okay, so Sheena, if instead of 1 we had 2, isn't 2 the same thing as 2 by 1?
Yes, sir.
So, and I can write 1 as what? What can I write 1 as?
Log 5, 5.
I have something to the side, so I could always bring that up, and this would turn to what?
Log 5, 2.
5
Log
squared.
5, 5, 2. Mm-hmm.
Right. Cool. You need to know how to handle situations like that.
Okay.
Do we have a single log on both sides?
Yes, sir.
Right, so we could drop the logs. If we drop the logs, we're going to end up with 3x plus 7 all over x minus 9. And that's going to be equal to what? Tell me, Sheena, that would be equal to what?
0.
0. Remember, so I was saying I'm dropping the logs. So I have log base 5 here, so I drop that. What I have on your right-hand side?
Oh, I have 5.
I have
Wait.
log base 5. So I would drop the log base 5 and I would remain with 5. Yeah.
Mhm.
So now I could write 5 as 5 over 1, and I'm going to cross multiply. So that's what I'm going to do. I'm going to cross multiply. So, Sheena, if I cross
Yeah.
multiply, what's 1 by 3x plus 7,
3x plus 7.
right? What is x minus 9 by 5?
5x minus 45.
Right? So you're just going to multiply everything here by 5. 5 by x is 5x. 5 by minus 9 is minus 45. I want to find for x. What's the next step, Sheena?
Oh, sorry, right. You could say that like this.
Tell me what's the next step.
Yeah, carry 5x over the equal sign and the plus the 7 over the equal sign.
Right, so I can end up with 3x. 3x what?
Minus 5.
Minus 5 what? Eggs, monkeys?
Minus 5x.
Oh, 5x, right? And we move across the plus 7, so it wouldn't be there anymore. So that'll be equal to what?
No, minus 45 minus 7.
Right, what is 3x minus 5x?
Minus 2x.
What is minus 45 minus a lot?
Minus 52.
Right, I want to find for 1x. So what I could do?
Divide both sides by minus 2.
Right, and I was telling Serena, another way to think about it is you're moving across the minus 2 over the equal sign. So Sheena, if I have minus 2 by x and I move it across, that would turn to minus 2 what? If it was multiply before, it would turn to what?
Divide.
Yeah. So I could just divide by minus 2. So x would be equal to minus 52 over minus 2. Either one is correct. So negative divided by negative is a plus. And 2 into 52, that's 26, I believe.
Yes.
Right? And Shina, how would I check to see if my answer is correct?
Yeah, apply it back into the original question. Every time I see x, you put 26.
So let me see if that is the case. So I would put log base 5, 3 by 26 plus 7 minus log base 5, 26 minus 9 equals to 1. So, Serena, what's 3 by 26? If I do some mental maths, I'm looking like 78.
Yeah.
Is it 78?
Yeah.
And 78 plus 7 is 85. Just verify that. Serena, that's correct?
Yes, that's correct.
Okay, cool. And that'll be minus log base 5. 26 minus 9, that is 17. And that's supposed to be equal to 1. Now, guys, if we using the rules for logs, right? And a minus in two logs, and that would be, and I would apply the quotient rule. Shana, tell me, and I would apply the quotient rule.
Yes, sir.
So what would I write over here?
Log 5, you can put 85 over 17.
And that's supposed to be equal to 1, and it's supposed to. What is 85 over 17?
5,
Where's log base 5, 5?
1.
1 is equal to 1. Are we correct?
Yes, sir.
Yep. Let me put a celebration emoji. A meme, I mean. Yay, we got through. Big up us. Right. I want to move on to a slightly harder question now.
So stop now for 1 second, huh?
Okay, no problem. So Serena, so far you getting everything correct, right?
Yes, sir.
You know what I done, right? You just give off the vibe that is a maths boss. You just give off that vibe.
Hmm? Thank you.
Yeah, you know what they say, real recognize real. It kind of sound like you like maths.
I do.
Yeah, I could I could I could almost smell it off of you. Like I could smell the love for maths. That's good. So like, I guess in your future job you want to do something with maths.
I want to be an accountant.
Okay, nice, nice. If you want to make real money, you could look into actuarial sciences, which is like real maths, and it's like calculating risks for business and optimizing profits and using maths. Real cool.
I'll look into it because I'm not sure. I'm not too sure what that is.
I will show you. I might just type it in the chat. Right. So here what? These are the last two questions I'm going to do to end off. Right? These are the last questions I'm going to do to end off. If you all could answer these questions, you're not gay. Like you're certified. You're ready. Like you're ready. And I also want to do the 2025 question. Let me just put that in one time. Just get that real quick. Okay, nice. I have to show you guys how to solve questions like this. No problem. All right. So attempt these two questions. I'm giving you all 5 minutes and 30 seconds. Not much time, but just do as much as you could do. Okay, Serena, how things going?
I got an answer, but I'm gonna check to see if it's valid or not.
Okay, Jeremiah, you're joining AdMats. Yeah, I know you were just going to do Form 4 maths and AdMats. Form 4 maths and Form 5 maths with me. Do you want to do AdMats as well? Yeah, okay.
What's it?
All right. So Serena and Sheena. Let me know what's going on, guys. I have like 1 minute remaining. Serena, what's going on? Serena? Sheena? Guys, I leave my
Yes, sir.
down. I leave my dangling boy. I feeling like cliffhanger. I don't know if you know who Cliffhanger is. Sheena, you ever watch this thing with the lions? Sure if you know what I'm talking about. Beyond the Gates or something.
I don't think so, sir.
Okay, that's because I read old.
Oh,
All right. Serena, let me see what you sent. All right, so there was multiple ways you could have worked question 4, right? Multiple ways you could have worked question 4. So, Serena, I want you to walk me through how you did it, right?
Okay.
Yeah. So, Serena, the first thing, do we have the same base for everything? Is everything the same base?
Well, the one isn't.
Wait, say that again?
The one isn't to the same
Yeah.
base.
This one kind of suspicious. This one is very suspicious. So we have to convert everything to log base 10. So if I do that, I'm going to end up with log base 10, 4x plus 9, and on the right-hand side, that 1 is going to change to what?
Log base 10.
Right. Shayna, did I confuse you there?
no, sir.
No? Okay. And then I have log base 10, 3x minus 2. Now, Serena, I see that you went down the route of using the quotient rule. What if I told you you could have also used the product rule?
I didn't see that at first, but I see it now.
Yeah, you see it now, right? I hate working with fractions, so I would prefer to do this,
Okay.
right? So, that would be log base 10, 4x plus 9, and sorry, now on the right-hand side, you're seeing log base 10 plus log base 10, 3x minus 2. So tell me, I have the same base, and I'm adding, so I could write that as what?
Open brackets 10, another open brackets 3x minus 2 close brackets, and then close brackets again.
Right. Shayna, make sure I'm put your brackets, eh? I'm telling me if you're lost with anything I did so far.
No, sir, not lost it.
Okay, good. So Shayna, I want you to take it from here, right? So Shayna, do we have one log on either side?
Yes, sir.
So we could drop the logs. If I drop the logs, what would I write? What am I going to write?
4x plus 9 equals 30x minus 20.
Right. For anybody that's confused or if you're looking at this video at a later time, Shayna skipped a small step. It's fine, but I'm gonna put the full work in here. So if I purely just drop the logs, I would have 10 by 3x minus 2. If I then use the distributive law and expand, I would end up with 10 by 3x, which is 30x, and 10 by minus 2, which is minus 20. What's the next step from here, Shayna?
You move the 2tx over the equal sign and the positive 9 over the equal sign as well.
right? So we're gonna end up with what? 4x
4x minus 2tx and minus
mm-hmm.
20x
No, minus
minus
20.
9.
You said minus 20x there.
Oh, sorry.
Yeah. All right, that's okay. Right? 4x minus 30x is what?
26x.
20 minus 26x. Right? And that'll be equal to what? It's minus 20 minus 9.
Minus 29.
Mm-hmm. What's the last step?
Get the x alone, so divide both sides by minus 26.
Right? And so x would be, so this one kind of strange, right? We didn't get a integer value. I hope I'm not confusing now. Yeah, when I say integer, I mean like positive or negative whole numbers. That's what I mean. You're not gonna get a whole number here, right? So you're gonna end up with x is equal to 29 over 26. Serena, did you get that?
Yes, sir.
Yeah, you did. Big up you. I real proud of you now, Serena. Big up yourself. Right? Big up yourself. Now, we only got one answer, and this answer was positive. So, Serena, I think it's safe to say that answer is valid, right?
Yes, sir.
And Shayna, if I wanted to prove that my answer is correct, what would I do?
Yeah, put back x into the original question. So every time we see x equals 29 over 26.
Right? So I would put log base 10, right? 4 by 29 over 26, plus 9, and that would be equal syntax error. What? It's weird. That's very weird. Log base 10. What did I do wrong? Log base 10, 4 by okay. All right. So Shayna, if I plug it into the left hand side, I'm getting what? What am I getting?
1.13
With a
if you
one
run those are
point
two decimal pieces. I mean two decimal
one
pieces.
one 1.13, right? So Shayna,
Mm-hmm.
if I plug it into the right hand side, what am I supposed to get? Since it's an equation, I know equal. What am I supposed to get?
The same thing.
I'm supposed to get the same thing, right? Let me see if that's the case. So 1 plus log base 10, right? 3, open bracket, close bracket, on the inside fraction, 29 all over 26, right? Minus 2. So when I press equal, what am I supposed to get, Serena? What am I supposed to get?
1.13.
Bam. Again, math is very cool, right? So this is the proof. This is the reason why it works. Because it's an equation. It's an equation, equal. When you plug in the answer you get, you're supposed to get the left-hand side equal to the right-hand side. Now, you have a choice. If you want, you could write your answer to 2 decimal places. Sometimes it would specify. So 29 over 26 is what to 2 decimal places? What is 29 over 26 to 2 decimal places?
1.12.
1.12, that's correct. 1.12 to 2 decimal places. That's correct. Now, this is not the only way you could have done the question. This is not the only way. So, Serena, I want to just go through how you did it, like really, really fast, like speed run it.
Sure.
Right. So, Serena, I'm going to just copy and paste what I have here. So, um, I have this over here. Right. I can't big you up, check it. Or Big up, big up. Right? Wait there, wait there. Let me put a big up Shayna over here too. Big up Shayna. Nice. Yeah, so Serena, explain your method.
Okay, so what I did was I shifted the log base 10 3x minus 2 across the equal sign, and because I shifted it, the positive sign would now be negative.
Right? That's 100% valid. And you probably would have done this to make it look like more familiar equations,
Yeah,
right?
and because it would be log base 10 4x plus 9 minus log base 10 3x minus 2, you would use the quotient rule or law. So
Mm-hmm.
in the next line, it will be log base 10 4x plus 9 over 3x minus 2, which equals to log base 10 to 10, because 1 is log base 10 to 10.
Right? And I could do what with the logs now?
You could remove the logs because there's only one equation on each side.
Now, one log term on each side.
One log term on each side. So you could remove
Mm-hmm.
the log. And then I cross multiply, and I got 4x plus 9 equals to 10 open brackets 3x minus 2 close brackets.
Right? I could write as 10 over 1. It's the same thing.
Mm.
Going to cross multiply.
Mm-hmm.
What's 1 by this entire thing, Serena?
4x plus 9.
Right? 1 by anything is itself. What is 10 by 3x minus 2?
Well, it would equal to 30x minus 20, but I wrote it as 10 open brackets 3x minus 2 at first.
Oh, okay. All right. And then the next step is basically the same thing as over here, right? It's the exact same thing. So I could just copy and paste from this point. All right, so this is the cool thing about maths. You could do it different methods and you'll still get the same answer once you do sense. Right? Once you do sense, you'll get the answer. So this is a tough question. This is a tough cookie to crack. Right? Sheena, I'm gonna request your help over here. Like this is one of the toughest questions. So Sheena,
So
any si-
I do some of it, but I don't know if my answer correct because I have like 1 over um 9 log 5. So yeah.
okay, that's kind of sounding correct. So give me a second, right? I just want to explain something. So Sheena and Serena. So Serena, in all the previous questions, where was the x term? Was it outside the log function or was it inside the log function?
It was inside the log function.
So this question is a bit different, and we could agree it's a bit different.
Yes.
Yeah. If I told you that this was just a fancy algebra question, would you believe me?
Probably, yeah.
I'll show you
Yes,
what I mean. I'll show you what I mean by that. Different from the others. In this question, the unknown is not inside the log function. So in other words, this is just a glorified algebra question. This is just a glorified algebra question. So let me show you what I mean by that, right? Serena, isn't log 5 a number? Like technically, and it's a number. If you put it into your calculator, and that's going to be a number.
Yes.
Before we continue, I just want to let you understand that LG, LG means the same thing as log base 10. That's what LG means. You should know that LG means log base 10. So, oh, check this, right? You see 5x log 5? That is really 5 log 5, 5 log 5, 5 log base 10, 5. So, another way I could write that is I technically could write it as 3.49x. And that's just basic algebra, Serena. And that's basic algebra.
Yes, sir.
Yeah, but you see, in AdMods, we like to be a little more precise with it. So you're not gonna do that. But it wouldn't be wrong. It just wouldn't be the exact answer. So Serena, we recognize it's just a basic algebra question that's looking hard. If it's a basic algebra question, and you would want all the x terms, and you would want it to the side, you wouldn't want no powers. You're probably confused by what I was saying. So we have the x term to the side here already. Do we have the x term to this side?
No.
Could I apply any rule to get this 2x to the side?
Yes.
Yeah, I want you to recall what rule is that. That's what rule. Recall.
C log A B, and you could move the C to be the power of B.
And it's work back and forth, right? Vice versa. And this is called the what rule, Shina? Which rule is this called?
The power? No.
Right. This is the power rule. Nice. That's the power rule. So this is what we're gonna do, right? I'm going to write 5x log 5, and that Serena, what do you think what do you think this is gonna turn to?
It would be 2x log 25.
Right. And that'll be equal to 1.
Mm.
Yeah? Yeah or no?
Yes, sir.
And if we wanted, we could have pulled out x from this and this. This is the part where I might lose some people. There's two ways you can do this question. I'll go through two. I'll go through the two methods. But Serena, and I could pull out the x terms if I wanted.
This one kind of confusing to me. I'm not sure.
Okay, Serena, do we have a x in this term?
Yes.
Do we have a x in this term?
Yes.
So if I were to pull out the x from this term, what would I write inside the bracket? So let me show you what I mean, right? Imagine you had 9x squared plus 8x. If I were to factor out x, what would I write on the inside?
9x and plus 8.
Sure. So if I pull out the x from this, that's the same thing as 5x log 5 divided by x. What would I write?
5 log 5.
Right, I would write 5 log 5. And if I pull out the x from this, what would I write?
X open brackets 2 log 25.
So I'm just going to write 2 log 25, right?
Oh, right, yeah.
And that'll be equal to 1. On a scale to 1 to 10, how confused are you?
5 out of
You're
10.
real confused.
A
You're
partial.
probably saying why I didn't just add these and get 7x. Are you saying that?
No, I don't think
No?
so.
Okay, because that'll be wrong. So we're trying to find for x, right, Serena? And that's what we're trying to do.
Yeah.
So we need to pull out x from this and this. So if I pull out x from 5x log 5, that's going to be 5 log 5. If I multiply it back out, I'll get back 5x log 5. You with me there, right?
Yeah.
And I have 2x log 25 here. If I pull out x from that, I'll just have 2 log 25. So what is confusing you, Serena?
Um, the fact that I pulled out the X. like I
Yeah.
understand it. When you
Yeah, so Serena, you see, now we're pulling out the x, right?
yeah,
So you understand what we did, right?
yes.
Cool.
But the thing is, I don't understand why you did it. That's the only thing.
All right. I'm gonna share our reason why. Let me just say we had a question like 9xy plus 7xy squared is equal to 18. And the question wanted us to make x the subject. Make x the subject. How would I make x the subject here, Serena?
Uh,
Do you
you
know?
try to get the x alone.
Say that again.
You try to get the x alone. So
And how are you going to do that? That's the question, Serena. How are you going to do that?
pull out the x.
Exactly. And you would pull out the x. So I'd write, what would I write on the inside?
9y plus 7y squared.
Equal to 18, right?
Mm-hmm.
And the next step would just be to divide by 9y plus 7y squared on both sides.
Yes.
I'm asking a question. What? Aren't I doing the same thing over here and over here?
Yes.
Yeah. You understand?
Yes, sir.
I'm trying to find for x. I need to isolate x. So I need to pull out x from everything. I need to isolate it. I can't have x anywhere, right? So just like with this example, right, where I divided by 9y plus 7y squared on both sides, what do you think I'm going to divide by on both sides here?
You're going to divide by 5 log 5 plus 2 log 25.
Right? So this is going to turn to 1 over 5 log 5 plus 2 log 25. Now, this is not the simplest form, right? There's a simpler way you could write this. So, but this answer is correct. This is the correct answer. So, Serena, and I could write 5 log 5 as log 5 to the power 5,
Yes.
and I could write 2 log 25 as log 25 to the power 2.
Yes.
Okay, and aren't I adding, and I have the same log base?
Yes.
Yeah. So I could write this. So check this, right? I would write it as log open bracket 5 to the power 5 multiply by 25 squared. Did I do anything that was confusing?
No.
No? Okay, good. And I'm going to plug that into the calculator. Here what? In AddMaths, we want the answer in the exact form, and we don't want no round off answer. We want the answer in the exact form. So I'm going to write 5 to the power 5 multiply by 25 squared, and that's going to be quite a big number. Yeah, it's quite a big number, right? So x would be equal to 1 over log, that is 1,953,125. That's what my answer is. That's the exact answer. It doesn't get simpler than that. All right, so Serena, was this one of the harder questions?
A little bit because I was confused at first.
You understand it now, right?
Yes.
So, Shayna, I sure you get this answer. If you were to simplify your answer, it would work out to this. Right? So Shayna, I'll do the method you did just now. But let's check if the answer is correct. If the answer is correct, when I put it into the first equation, it's supposed to give me 1. So I'm going to write 5 by x. We found x to be 1 all over log base 10. 1,953,125. Uh-huh. Mm-hmm. Right, I'm going to multiply that whole thing by log base 10, 5. Then I'm going to say plus 2 by x. Again, we found x to be 1 all over log base 10. 1,953,125. Mm-hmm. right? And I'm going to multiply that by log base 10, 25. I should get 1 when I press the equal sign. And Serena, what do I get?
1.
Wow. So that had to be the correct answer, right? So Sheena, you understand? I'm getting 1. So that's the correct answer.
Yes, sir.
Right, now let me show you another way can I do this question. So Sheena, let me handle this. So I have 5x log 5 plus 2x log 25. Actually, wait, it has so much ways you could work this question. There's so much ways you could work the question out. Right? Log 25 to the power 2x is equal to 1. All right. So Sheena, is it possible to write 25 as 5 to some number?
5 squared.
Right? So Serena, follow along and tell me if you understand this as well. So 25 is the same thing as 5 squared. So I could replace 25 for 5 squared to the power 2x. Okay. And so, Sheena, what is 5 squared to the power 2x? That will be log what? Log 5 to what power?
Oh, 4x.
Right? And that will be equal to 1. Then I could apply the power rule, and that will be equal to what, Sheena? That'll be plus what?
Plus 4x log 5.
And that will be equal to 1. Okay. So Sheena, if you look, we are seeing 5x log 5 and we have 4x log 5. Altogether, that's going to be 9x log 5. Now, to make it less confusing, we're going to factor out the common terms. So Sheena, do we have x in both of these terms?
Yes, sir.
Do we have log 5 in both of those terms?
Yes, sir.
So actually, here, well, let me just pull out x, right? Because we're trying to find for x. Let's just pull out x. If I pull out x, what am I going to write on the inside? Yeah, Sheena,
5
if I
log 5.
5 log 5 plus what?
4x log 5.
I pull out x. I factor out x.
Oh, sorry. 4 log 5.
And that'll be equal to 1. What is 5 log 5 plus 4 log 5? Imagine you had 5 log 5s, and then you add 4 more log 5s. How much log 5s
9
you
log
have?
5.
9 log 5. And that'll be equal to 1. Serena, what's the last step there? What's the next step?
You divide both sides by 9 log 5. So it'll be
Right?
x equals 1 over 9 log 5.
And what do you guys think the last step is?
You could simplify it by.
That's what you're thinking.
Yeah.
And what do you all think 5 to the power 9 would be? This long answer over here, right? Yeah, that's another way you could do it. Everybody understand?
Yes, sir.
Nice. This was one of the
Yeah.
harder questions. It's one of the harder questions. If you can understand this, you're really, really set. So next class, I'm going to move on to dealing with exponential equations where you have to actually apply logs. And I'm going to move on to questions where you would have to apply logs on both sides to make something the subject of the formula. So that's what we're going to cover in the next session, right? And if I get a chance, I would like to move on to log graphs. Just to clarify, none of you guys did this in school as yet?
No, sir.
No, so we
That's
didn't do that.
That's crazy, but we could do it here, don't worry. All right, so once we finish with this, we finish with a big chunk of the syllabus, log, certain, and the C's are like a big chunk. All right, and after I finish with that, I want to move on to coordinate geometry. That should be a easy topic. Right? So, yeah, guys, thanks for coming to class. I will see some of you Saturday. Shina, seeing you Saturday.
Yes, sir.
Right. 9 to 11,
Yes, sir.
right? I just have to specify because I know how to say 10 to 12 at any pass. So, yeah, have a blessed night, everybody. Later.
Bye, sir.
Bye bye.